Solving radical equations. So this is what we're going to do when we have a square root sign in our actual problem. Okay, so we want to review our concepts of how we solve equations. So the opposite of add is subtract. And I'm just going to put a minus sign. What is the opposite of multiply? Divide. So what's the opposite of square root? Square. So opposite of square, square root, opposite of square root, square. So when we solve equations, we are using opposite operations. So now we're just going to add in the square and square root operation. Before we just had add, subtract, multiply, divide. Now we're adding in the square and the square root. So solving an equation that has a square root in it, we can use this acronym here, IRSC. Okay, where I is going to stand for isolate. I don't know what's going on in the handwriting. Isolate. That's not much better. All right, isolate. Then R is going to stand for raise. S for solve. C for check. Okay, so let's go through those steps with this problem. So isolate the radical on one side of the equation. So you want to isolate this square root. So anything that's not in it needs to go to the other side. So this is 2 times the square root of x plus 1. So to isolate, I'm going to divide both sides by 2 so that these 2's can cancel each other out. This is going to be square root of x plus 1 equals negative 12 divided by 2. Okay, then R raise each side to the power equal to the index of the radical. So we undo the square root. So right now the x plus 1 is kind of like in jail underneath that square root. So we're going to do the opposite index. So in this case, that's just square. Both sides, we free the x plus 1, okay, because the square root and the square undo each other. This just becomes x plus 1 with no parentheses around it, nothing above it. And then negative 6 squared is negative 6 times negative 6, 36. Then we just have a regular equation. X plus 1 equals 36, so S is solved. So we get x equals 35. Now, this next part is really, really important. You have to check your work in these because you could get what we call an extraneous solution. That's not going to fit in this blank. An extraneous solution is when you solve the equation, it works, but when you plug it back in, it gives you a false statement. Okay, and we'll look at an example of that. Now, I'm going to take this 35 and I'm going to check it in the original problem. So 2 square root 35 plus 1 equals 12. What's it supposed to equal? It doesn't equal negative 12. So in this case, because I'm showing you an example of it, this is actually an extraneous solution. So you have to cross it out. If there's no other solutions, then this is a no solution. Okay, because 2 times the square root of 35 plus 1 does not equal negative 12. It actually equals positive 12. Okay, so we always have to check it because of that. Now, a shortcut is if there's a negative on this side of the equal sign, most likely it's extraneous. Okay, but you should be checking anytime you start with a square root in the problem. So that's part of the actual process of solving it. Okay, so let's look at example 2. We have square root of x minus 19 equals 5. I isolate. Is this already isolated? Yeah. Okay, then R raise. So we're going to Take both sides, we're going to square them. So the x minus 19 now free from underneath that square root, and 5 squared is 25. Then s, I'm going to solve. I'm going to add 19. And let's see, that should give you x equals 44. And then c, I am going to check. The square root of 44 minus 19 equals 5. And it does. So I'm good to go. So this time I get to keep my answer. X equals 44. Okay, so let's take a look at example 3. So what do you notice right off the bat on this one? There's a negative, so it's probably an extraneous solution. Let's check. So this is isolated. So I'm just going to go straight to raise. So this will be 5x equals 25. Solve. I'm going to get x equals 5. Okay, then I'm going to check. Square root of 5 times 5. I don't think the square root of 25 is negative 5. It is positive 5. So does not equal negative 5. Therefore, this is extraneous, and this is a no solution. Now, sometimes you're going to have a problem that has a square root on both sides. So if that happens, they're both isolated, just go ahead and raise. So we can still follow the steps here. So we square both sides, and that just means we get a linear equation without the square root. And then we can go through and solve. And then we have to make sure it works. So let's say I subtract the 2x from both sides. That's going to be 1x minus 2x, negative 1x plus 7 equals 1. Subtract 7. I'm going to get negative 1x equals negative 6. Divide by negative 1. X equals positive 6. And then I just have to check it. So I get the square root of 6 plus 7 is going to give me the square root of 13. And then the square root of 2 times 6 minus 1 is going to give me 11. Is that right? Yeah, so that should be extraneous, right? Those are different. Square root of 13 does not equal the square root of 11. And I want to check that in my calculator because they should be the same thing. So let's see here. Square root of 6 plus 7, 3.6-ish. Square root of 2 times 6 minus 1, 3.3. So definitely not the same number. So this is also extraneous. So we get a no solution. So that's why it is important to check. Even if the problem looks relatively simple, like this one did. Okay, so we have 3 practice ones. On the next page, go ahead and work on those. Notice the first problem has a 4th root. So after you isolate, when you raise, you're going to raise to the 4th power instead of the 2nd power. All right, let's go ahead and take a look at these. So for my first problem, I want to isolate. So this plus 1 is not part of here, so I'm going to subtract 1 from both sides. So that gets this gone. So this is 2 equals the 4th root of 7x minus 1. What am I going to do next? Raise it to the 4th power. So since this is a 4th root, we're going to raise to the 4th power to undo that. And then we're going to do 2 to the 4th. What is 2 to the 4th? 16. Okay, so this 4th root, 4th power, that undoes the square roots. This is 7x minus 1. It's free now. So now we're just going to go through and solve. So we're going to add 1. We're going to get 17 equals 7x. And we're going to get a nasty fraction here. That's okay. Fractions are still numbers. So we just get 17 over 7. Then we want to check it. Okay, so we have 3 equals the 4th root of 7 times 17 over 7 minus 1 and then plus 1 on the outside. So these 7s are actually going to cancel, which makes things nice. So that's just the 4th root of 17 minus 1, 16, and then plus 1. So 4th root of 16 should be 2. Let's check. So 4 math x root 16, 2, and then plus 1, 3. So we're actually good to go here. This is 3 equals 3. That checks out. So we can keep our answer of 17 over 7. Any questions on that one? All right, number 2. Looks like I don't have anything to isolate, so what am I going to do first here? Square both sides, yes. Square both sides. Square undoes the square roots. This is 6x plus 7 equals negative 7 times negative 7, positive 49. And we're going to solve for x. We're going to subtract 7. We're going to get 6x equals 42. Divide by 6. X equals 7. Okay, let's go ahead and plug that back in. 6 times 7 plus 7, negative 7. We got that negative on the outside. That's not going to work. Let's check it. Square root of 6 times 7 plus 7. It's positive 7. So this one is extraneous. This does not equal negative 7. So I throw this out and I say no solution. And if you guys saw that right away, once this is isolated, if you look at the beginning problem, once that's isolated and it's negative on this side, you can see that right away. It's going to be no solution. So you can just write that. Okay, so let's look at number 3. Let me number these. 1, 2, 3, 4. Okay, who thinks the error was on line 1? Who thinks the error was on line 2? Line 3? Line 4? Not everybody's raised their hand. Who has no idea still? Or was just on their phone during that whole practice time and did not try to do the problems. Hence why you're not doing well in the class. Just saying. Okay. All right. Well, the error is on line 2. So somebody who raised their hand, what is that error? Well, it's actually, okay, it could be argued 1 as well. So some of you raised 1. So what did he not do from 1, between 1 and 2? Go ahead. Yeah, so from 1 to 2. So it's really, I mean, you could argue both lines, right? Technically, it's on line 2 because you can't do that, right? But really, he should isolate. So he forgot to isolate in the beginning. So subtract that 13. So you have square root of 3x minus 8. Now this is going to be 17 minus 13, so it's going to be 4. That was that error there. We forgot to isolate, so very first step. Then the rest of it, we did raise, solve, right? So we did everything else. We just forgot that first step of isolating. So you can't raise until the square root is completely isolated. So now we can raise. And let's see here. These cancel out. We get 3x minus 8 equals 16. 4 squared is 16. Then I am adding 8 to both sides. That's going to give me 3x equals 24. Divide by 3. And I get x equals 8. Much nicer solution there. I'm going to go ahead and check that in the original. So I have square root of 3 times 8 minus 8, close the square root, and then plus 13. 17. So it works. So I can keep that answer. Okay, biggest takeaway on this section, though, you have to check each one for those extraneous solutions, because as you can see in our multiple examples, they do exist.